data storage, right? And data storage is key. When you understand the difference between how a database stores data and how a tabular model stores data, right? It's so much easier. So let's have a look and see if we can figure it out in nice and simple terms, yeah? Champion. All right, lads and lasses, welcome along. Tokens Tuesday yet again, eh? Let's look at this hot topic, eh? So that you really need to understand the differences between and about and why they're like that, right? So let's celebrate some of these differences. Power BI is about tabular analysis of data, okay? We take a tabular data model and analyze our data. A lot of that data is going to come from databases though, okay? And at some point we have to take from source and put it into analysis engine. So we have to go from a database storage model into a tabular data model. And we have to understand the differences. And once you understand the differences, a lot more about Power BI and tabular makes sense. So databases, for example, they optimize their data to be stored by a mechanical hard drive, right? If you look, if we zoom in here on our hard drive, you can see we've got a little head here, right, and a platter. So you want the head to move as little as possible up and down, okay? Simple way of thinking about it. So you put your rows next to each other, and the whole row is all everything to do with each other. So like a row is together, and then you put rows from the same table together on the disk, right? So that the head just doesn't have to move. You spin the disk, and you read it from there, yeah? Makes sense. Right, so everything's kind of predetermined. Your tabular data model is about analytics, okay? Nowadays, we can also store it all in RAM. So it's all in RAM, and it's looking at it by a column. I want to know the sum of sales. That's the sum of one column. That's all I want. And so because it's like that, you can start to say, well, what are the opportunities to compress the data, which we couldn't do with the mechanical drive version. We couldn't compress that data. Now we can compress it because we can say, well, what have we got for starters? And then what do we have in terms of uniqueness within that column? So what do I mean? If we look at this in detail, right? Remembering I wasn't hired and I haven't come into this for my artistic merits, right? But if we took the track on a hard drive, so like the bits going round and round in a spiral into the center, right, and unravel it a little bit, you'd kind of get to this point, wouldn't you, behind the scenes, where we've got a row on it, which is a certain amount of space, and then within that certain amount of space, we can see the columns that go up to make that certain amount of space. And then that certain amount of space is going to be used for each and every future row in the table and any previous. So we've kind of got that there's an idea that it's a consistent amount of space on a track based on the size of the schema determines a row must be, or the maximum size a row can be, right? Okay. Tabular, on the other hand, goes about it all differently. In fact, tell you what, let's get rid of this ugly thing. Let's get rid of me face, right? And we can crack on. So tabular will look at it and it will say, I've got 4 columns here. I need to work out how I can compress them. So it'll look at each one and see what the uniqueness is. And then the less unique a column is, right, the more it can be compressed. Right? Compress other columns as well differently, but that's the general rule of thumb, right? So we've kind of got a compression schema here that will then allow tabular to compress that model or that table and store it most efficiently, knowing that we're going to just want to do something with a column, like summer sales from this date, okay? It's optimized for analytics because of that, and it can apply compression, which means you can store more in RAM, which means you can D more. And the last thing to remember is, as long as you are using good storage algorithms within your Power BI model and within your tabular model, right, you will find your DAX is much more performant because the storage engine allows for parallel processing of requests. So remember, there's a key difference between going from the row by row based of a production system, like a transactional system. So it'll be like Ross wants to buy something, or Ross has an order from last Thursday for 50 gigs of RAM, or for 20 computers, or for 10 Greg's pasties, right? Whereas we might say, how many pasties did we sell last Thursday in a tabular sense, right? So it's a transactional versus the analytical side. And that's the key. And in practice as well, you'll only ever go one way, won't you? You'll only ever go from your database to your tabular. It tends not to go the other way. Just, So if someone says, oh, I want to go the other way, you might want to advise them otherwise. But, stranger things have happened, eh? So what do you reckon then? Okay? Tabular data models. They are the right thing, okay? They are very good, they're very efficient, and they're very effective, okay? The way traditional databases were written, okay, and to be fair, they are still working very much that way even today. It'd be nice to say they're not, but even with solid state and that kind of thing, it's not, it makes sense to keep the structures together. So your tables, the whole way it's all prepared, the whole way the memory is allocated, like you're basing it on how many rows of data we're going to have to add, which then allows how much of this. And you'll find that's the realities for traditional relational databases. And probably it will still be the case in 10, 15 years' time. There's a lot of core, deeply embedded processing within the structural languages of them, like SQL, that it's not an easy thing to just change it. And when we think that, is there a need to? Transactionally, the main way these databases are working, it is very much about what's happening at this row. This sales order is being processed. This sales order is being processed. This one, I have to update it. Who's that? Who's the customer? It's not analytical. And it's the difference between the two that we need to understand. So I hope you enjoyed that, right? Didn't forget, like and subscribe down below. Jump on over to our website, support us. You guys make it all possible. For now, though, take care of yourselves. Stay safe. All right.